The beginning part of this is no calculator. I had lots of calculators left here. Yep. Starting off with our log properties, we have a couple up there. We are going to clarify a little bit because not very often are they just solo properties. A lot of times you will have a mixture of these properties. We will use them to do what's called expanding and condensing our functions. I hesitate a little bit on the product and quotient properties up there, but I'll tell you why in just a second. But the rule is this. If it is a multiplication on the inside, and notice these are both in the numerator of that fraction, although we don't see a fraction, right? That I can do what's called expand this logarithm. It's kind of the same idea as factoring. We can pull it apart into giving everything that is a term, like the x and the y, the same logarithm that is out front, log base b. And to expand this, it would look like this. Log base b of x plus log base b of y. The quotient property is very similar. Every term gets the log base b. The difference is from multiplication to division. When it comes from the denominator, it is subtraction. So to expand that one, it would look like log base b of x is in our numerator minus log base b of y. The y came from our denominator. And then our power property says that if I have an exponent on the variable that's inside of my logarithm, that exponent can be slid out front of my logarithm and become a constant multiplier. So the p that is the power here on the x can slide in front of our logarithm and become p times log base b of x. Now, the clarification on the product and quotient property is this. These commonly get confused for each other, and here's what I want you to remember. It's all the same idea, but if something comes from our numerator, it will always have a plus sign in front of it or a positive in front of it. If a term comes from our denominator, it will always have a subtraction in front of it. And it doesn't matter how many things are coming from the denominator, and we'll look at an example like that later. But whatever comes from our denominator, negative in front of it, whatever comes from our numerator, positive in front of it, order does not matter. Okay? Today we're going to have basically three types of directions for all things that kind of look the same. The first type of directions we're going to see is this word that says expand. When you are expanding, you should give a logarithm to every term that you see in there. So every number, every variable gets its own logarithm. And then we appropriately will have a plus or a minus, whether it came from our numerator or denominator. And then as we'll see later on, we'll get rid of any radicals and any exponents as well. So this is a very basic first example, log base 2 of 6x. The reason I put this one up here is a lot of people overlook a constant multiplier of the 6. It is a term as well. The 6 and the x both get a log base 2, both coming from the numerator. So we would have a positive log base 2 of 6, a positive plus log base 2 of x. That is called expanding. Adding one more layer to that, something that has exponents in it, log base 5 of x to the third y to the sixth. Again, every variable, every number that we see in there is going to get its own logarithm. So we have an x, we have a y. Both of them will get a log base 5. They're both in the numerator, so they'll both be positive or plus. So I would start expanding by saying log base 5 of x to the third plus log base 5 of x to the sixth. The next layer in expanding is that we don't get to leave any fraction exponents. So if you or any exponents. So if we have any exponents, now all of those will slide out front of our logarithms and become constant multipliers. So it would become 3 times log base 5 of x plus 6 times log base 5 of, oops, that should be a y. Y. That would be fully expanded. If you were to get done and you had more than one term in here connected with multiplication or division, you're not done. You would want to keep going. The only thing that could be left in there that's more than one thing would be something attached by addition or subtraction, which we'll see an example of in just a second here. Any questions so far? Okay. Adding one more layer to this would be radicals. So on this next example, again, expand means we put a logarithm for each variable, each number that we see. In this next one, it says natural log of AB over the cube root of C. So we'll have a natural log for A, for B, and for C, would be the 3 letters that we see in there. The rules for natural log do not change. It's just a log base E, so all the logarithm rules that we just saw still apply for this. So it will become natural log A is coming from the numerator, so it's a positive natural log of A. B is coming from the numerator also, so positive or plus natural log of B. C is coming from the denominator, so minus natural log of the cube root of C. In our expanding rules, we need to focus on this last one here because there's 2 things that need to happen. First of all, if we ever have radicals, we're going to want to look at those as the fraction exponent. So instead of a cube root, I would write that as a 1/3. And then like we saw in the last example is that we don't leave any exponents. We slide them out front so that 1/3 would go sit in front of our logarithm. So our final answer would be natural log of A plus natural log of B minus 1/3 natural log of C. What we're doing right now is building a foundation for being able to solve these equations. So we're not going to get to that point today. We'll get there eventually, but we need to learn how to move things around in these so that we can eventually solve for different parts. The last variation we're going to see on expanding is when we have a plus or minus starting in our problem. So on this one you can see we've got this in this radical an x minus 7 and how we deal with something like that when doing our expanding. We haven't had a plus or minus yet. So in this one, natural log of 4 x to the third y squared over square root of x minus 7. Again, my different terms would be 4, x, and y all would get their own natural log. And then this actually is one term. I've talked about it before, but when something is connected to something else with a plus or minus, that's like the strongest bond in math. That cannot be broken. Same thing here, it's not going to get broken. So that is one more term, is that x plus 7, minus 7. Okay, so we can start by giving a logarithm to each of those 3 terms. Natural log of 4. These 3 are all positive because they're all coming from my numerator. Natural log of x cubed and natural log of y squared. This last term will be a negative because it's coming from our denominator. Natural log of the square root of x minus 7. And then a lot of cleanup to happen. Again, rewriting any radical as a fraction exponent. So over here, rewriting this as x minus 7 raised to the 1/2. The parentheses is a must. You cannot write that without the parentheses. Even after I slide that exponent out front, that parentheses will have to remain grouping the entire x minus 7 together inside your logarithm. And then slide the 3 and the 2 out front for those. We get natural log of 4 plus 3 natural log of x plus 2 natural log of y minus 1/2 natural log of x minus 7. Remember that x minus 7 is inside our logarithm, not times our logarithm. So it's not like you would distribute it through. Some people want to do that. It will just stay as x minus 7. If there's ever a plus or minus that starts in the problem, it'll just stay as is, grouped together with a parentheses. Okay, the one thing I don't have is a very basic example, but just so that we are clear, that if we were to have more than one thing coming from the denominator, something like log base 10 of a over bc, okay? Anything coming from your numerator is positive. Anything coming from your denominator is negative. So this would be log of a minus log of b minus log of c. And a lot of people want to make that a plus because that's multiplication. And I totally understand that, right? Can you see where that would happen? But anything coming from your denominator is going to be negative. And let me show you one other way you could look at this. If we had a fraction and I slid that c up to the top, wouldn't it just be c raised to the -1? And couldn't I do that with the b also? Slide that b up to the top and it would be b raised to the -1. So this would be like log of a, b to the -1, c to the -1. So if I were to expand it like that, can you see how the negative would end up in front of the logarithm each time we did that? That's why they both end up negative, even though it looks like multiplication down there. Any questions on expanding? Okay, so we just factored. We just pulled it apart. The other thing to do is FOIL it, put it back together, and that's what's called condensing. So when you see the directions asking you to condense, you're going to put it all back together. So undo what we just did. Okay, when you're done with this, you will only have one log left. So we have to remember, things with negatives come from our denominator. Things with positives come from our numerator. The first thing I would actually do is slide all numbers out front back to being exponents. Okay, so that would be step number 1. That if any of those happen to have been fractions, that I go back to making that a radical. And then anything positive numerator, anything negative denominator, one logarithm for everything. That when they sit next to each other, it will no longer be a plus, but it will be a multiplication as I condense this back together. Any questions on that? Yes. When I wrote the wrong number from this line to this line. Know what I mean. Not what I write. Other questions? All right, let's try another condensing. Again, doesn't matter if it's a log-based something or a natural log. When we are done with this, you will have one and only one left. No. So step number 1, if you have not done so already, take all of the numbers out front, slide them back to being exponents. After you've done that, if you've got a fraction, make it back into a radical. So the y to the 1/2, I'd make that the square root. Anything with a positive goes to our numerator. Anything with a negative goes to our denominator. We have not seen something like this when doing our condensing. If you have a binomial raised to an exponent, leave it alone. Don't ever write that out in FOIL. Just leave it. In this case, y squared plus 1 to the 4th. Don't do too much work. Okay? So all these positives, the x squared and the square root of y go, or x cubed, sorry, go to the numerator. This one had a negative, so that all goes to my denominator. Notice one natural log sitting out front of our fraction. Any questions on that? All right. The last type of directions that we'll see for very similar problems is evaluate. When it says evaluate, you're going to get a number answer at the end. We've already had problems like this. In fact, I probably could have handed you this problem on your quiz. It would have been tough, but you could have done it. But using the properties that we learned today, if you utilize those properties, can make a problem like this way easier. Something like this, initially I would have thought of it as 2 raised to something gives me the cube root of 32. Okay, I don't know what that is. 2 raised to something, I don't know, I can't think of that exponentially. But if I utilize some of my logarithmic properties, you can make this a lot easier to think about. For example, I could rewrite the cube root as a 1/3 exponent, right? And I now know that if I have any exponents, and I strongly encourage you to do this from here on out, every time you have an exponent in a logarithm, slide it out front. It will make the problem a lot easier to think through. 1/3 times log base 2 of 32. This is a lot easier for me to do in my head. 2 raised to what gives me 32? 2, 4, 8, 16, 32, 2 to the 5th. So this is 5. Bring down that 1/3. 5 times 1/3, straight across the top, straight across the bottom, would be 5/3. Questions on that? Not a requirement, but a lot easier to evaluate these if you utilize those properties. Rewrite it, slide it out front, get those radicals out of there. It'll make the problem a lot easier to think about. Okay, this one I want you to talk to your table partner. There's like 5 different ways to do this problem that we have now learned or could utilize, and I want to look at a couple different ways, all of which should get us to the same answer. But take a second and talk about what answer you would get by what method you want to use. Not hearing a lot of discussion happening. It's 8. This would be a non-calculated problem. Just saying. This is actually a very easy non-calculated problem. Once we get done talking about this, I think you'll see that it is a much easier problem. Guys, think about what I just talked about over here. What was my suggestion to make things easier? Move the exponents out of there, right? It's going to be a lot easier if you move those exponents out of there. So one of the ways, not the only way, there's actually a lot of ways to do this problem, but one of the ways you could do this problem is move those exponents out of there. Now, knowing what you know about math, if there's already a number there, and I'm trying to put the 4 there, what do you think we'll do with those two numbers? Multiply. Okay, so 4 times 3 is 12. Move that 2 out of there. There's already a 2 there. Okay. Now, again, a couple ways we could go about this, but let's talk about that natural log of e. It is 1. Yeah, same base, or it is e raised to something gives me e. That something has to be 1. The natural log of e is 1. So this is 12 times 1. This is the same thing, 4 times 1. 12 minus 4 is 8. Now, did anyone get 8 but do that problem very differently? What did you do? So you kind of went the other way, took the 3 this way and the 2 this way? Okay, keep going. Perfect. Yeah, so she condensed. Perfect. Okay, so we moved the exponent back to being exponents. The numbers out from being back to being exponents. She used the condense rule. Since this was subtraction, it went to the bottom. If they have the same base, you can subtract their exponents. 12 minus 4 is 8. Okay, and then if they have the same base of the logarithm as you as the exponent, you get the other number. Or e raised to something gives me e raised to the 8th, which means that something is 8. Why did I have to go through this different ways? Because that is like one of 5 or 6 different ways to attack the same problem and still get 8. And I just want to show you that we are now learning so many properties of logarithms that it doesn't matter. Find the one that jumps out to you, follow the legal maneuvers of that, and you will get to the correct answer. And sometimes you might have to try a different method because there's so many of them that sometimes with calculators one way is easier than another, or without calculators I should say. But any questions on that? Okay. This section is the first part of your assignment today, and it does take a little bit of pre-teaching to understand what the question is asking you up there. So I want to talk about what the directions are saying. It says express each logarithm, which our problem right now is log of 96, in terms of, and then it will hand you 2 different numbers, log of 2 and log of 3. Okay, now first of all, when it says express each logarithm, they're asking you to expand this into log of 2 and log of 3. To do this, what you're going to want to do, and you'll have several problems in the same section. We'll do a couple of log of 2, log of 3, is you either want to think through or just write out some powers of those numbers. So notice I wrote out powers of 2 and powers of 3. What do I mean by powers? I mean, what is 2 to the first? What is 2 to the second? What is 2 to the third? And give yourself a list to work from. Same thing with 3. 3 to the first, 3 squared, 3 to the third, 3 to the fourth, and so on. You may have to make the list longer if we end up not finding numbers there. But what I want to do is take the numbers in this list and take the numbers in this list and somehow find a product, multiply them together to give me 96. Let me give you a bad example. What if I tried to use 2? 2 times, let's see, 48 gives me 96. But 48 is not a number on this list, and I need both of those numbers to have come from this list of numbers. Okay, so take a second there and see if you can come up with a combo of these numbers that you're looking at right now that would give me 96. Let me know when you found it. Who's got me an option? 3 and 32. That works. Numbers off of this list, when I multiply them together, I get 96. Order doesn't matter. But what I'm doing is creating something that is made up of powers of 2 and 3. And I can even write 32 as 2 to the, we already talked about that one today, right? 2 to the 5th. And then you expand. Okay, all I have left to do is expand. So all I did was rewrite the number they gave me as powers of the numbers that they asked me to use, which you always will be able to do. And then expand. Both come from our numerator, so they'd both be positive. Slide that 5 out front. And that would be log of 96 expanded into 2's and 3's. We can do that same idea with division. Sometimes the division's a little bit easier to see because a lot of times it's numbers directly off our list. Okay, so I want you to try to expand that one, log of 32 over 9. I might rewrite them as the powers themselves just to help my head with the expanding part of it. 32 is 2 to the 5th. 9 is 3 squared. We didn't have to really do any like figuring out. They were sitting right there staring at me. But then I have to do the expanding part of it. Sliding those out in front. Subtraction for the fact that the 3 is coming from the denominator. And we have now fully expanded that logarithm. There is one that's going to catch us, and that is this. Same exact two numbers. I did not change direction. So still thinking through powers of 2 and powers of 3. And the number I give you is 13.5. It's not really jumping out at me. Okay, and I already gave you the hint on this one. But let's grab our calculators, and I want to show you something on your calculator. Don't type in log. I want you just to type in the number 13.5, and I want you to hit Math 1, Enter. If you did not already know this, calculator will do that work for you. What does it tell you that 13.5 is? 27 over 2. So what I had my calculator do is convert this decimal into a fraction. And when you run into this same problem on your assignment where it hands you this weird looking decimal, have your calculator clean it up for you. Type it into your calculator, have your calculator turn it into a fraction, and as soon as I turn it into a fraction, there it is. There's 27, there's 2, there's my powers of 2 and 3 that I'll use to expand this. Okay. Now, we just did this all in terms of 2 and 3. So this would be what? 3 log of 3 minus log of 2. Follow the directions that they give you. This one changes it to natural log, which does not impact what we do at all, but it changes it to the numbers 3 and 5. So I would recreate lists for myself of powers of 3, 9, 27, 81, however far I need to go, and powers of 5, 5 to the 1st, 5 squared, 5 to the 3rd, however far I need to go until I find numbers that work for that problem. You will run across, I would consider everything we've done so far pretty much non-calculator, other than the 13.5, okay? Should be able to be done not without a calculator, but you are going to absolutely run into one on your assignment that is such a big number. Grab your calculator, okay? Grab your calculator, let it help you think through those powers. Type it in. I would use the bigger number and just test out powers of that number until you run across one that works. Why do I pick the bigger number? Because there's less of them to try. Okay. Any questions on this? All right. Our last topic today is what is called change of base. And change of base, here's your title right here. This change of base formula, not super important for a lot of us, unless I don't get my graphing calculator. What change of base lets us do is evaluate a logarithm that is going to be an ugly decimal, not one that I would be able to do like in my head, with a scientific calculator or my phone calculator or whatever, using this change of base formula. So it says log base b of x can be rewritten picking any base I want, some other number, where I would do x in the top and whatever the original base is would be in the bottom. Why would I do this? Well, all calculators can evaluate for log base 10 and log base e, natural log. A lot of our calculators can handle this without our change of base, but not all. Okay, so for example, if I were trying to do log base 7 of 15, okay, 7 raised to something gives me 15. I don't know what that is. That's not a pretty number. That's going to be an ugly decimal. Okay, what it allows me to do is rewrite this as log base, and I'd probably pick log base 10 because that's what all calculators can do. You have that log button on your calculator, right? Log base 10 of the number inside over log base 10 of the original base. And I can type this in my calculator and it'll tell me what that is. Now with that being said, I want to be very upfront with you guys. A lot of your calculators, you will not be required to use this change of base. If you hit your math button and arrow down in that menu to about option 11-ish, A, it says log base. And if your calculator gives you that option, you can probably just type in a different base like this. Okay? If it doesn't, you have to know your change of base because you don't have an option. Okay? Let's try not using that log base. I'll have you try the log base function on your calculator in just a second. Let's try our change of base. Okay, so given this formula change of base, I want you to apply that to this right here. Log base 4 of 5. Okay, go ahead and try doing that one using your change of base formula. That's listed at the top of the page. Some of you are going to either have to write it in or put it in your calculator as a fraction, or make sure to close the parentheses before you divide. It's not going to be a pretty number. I can tell you approximately what it is. I know 4 to the third is 64, which is close to 65, so it's got to be something close to 3. Why do I say that? Because then I know that I've got something, at least an appropriate answer here. Okay, change of base. Log of the number inside divided by log of the original base. Okay, comes out to 3.011. Okay, any questions on that? Okay, now those of you that have the option, let's try your log base function on your calculator. If you don't have that option, you're going to keep practicing your change of base because you're going to have to use your change of base each time. Okay, so log base 1/5 of 25. And that answer is going to seem weird at first. I want you to think about if that's an appropriate answer. Did anyone else think that answer seemed weird? -2? Does that seem weird? No? Right? I could do my change of base, log of 25 over log of 1/5, right? I could, if I have that option on my calculator, go to my log base function in my math thing, but right now it's saying 1/5 raised to the something gives me 25. Well, I know 5 squared is 25, but to move it out of the denominator and up into the numerator, that's why we need the negative exponent, right? That's how I move things from one part of my fraction to the other. So it is -2. Any questions? Okay, last one on your own. Evaluate. Six raised to something gives me 4. So thinking about that, if I'm going from a bigger number down to a smaller number, that should be some sort of a fraction, right? What did it tell us? 0.74-ish, right? Okay. So it makes sense, right? That's how I'd get from a bigger number down to a smaller number. Can you try this on your calculators for me, please? On all of these, I had you do log. I want you to change your base formula, but not with log. I want you to do natural log. See if it changes the answer. Natural log of the number inside divided by natural log of the original base. Natural log of 4 divided by natural log of 6. .774. Yeah. It doesn't matter what you change the base to. Now, we would probably only pick log base 10 or log base e, natural log. But you really can change it to anything. It doesn't matter. It will always give us the same answer. Any questions on that? Okay. Your assignment is on page 185, 1 through 57 odds, skipping number 17.